see this property. This property is important. You can directly remember it, or what you can do is I'll explain you the proof. If you can understand the proof, it is okay. Otherwise, try to remember it. Okay. See this. If capital A is a square matrix, then show that adjoint of A transpose equal to adjoint of A whole transpose. The meaning of it is you take the matrix A and find out the transpose of it and then find out the adjoint of the resulting matrix, or even if you can find out the adjoint of the matrix A and then take the transpose, both are going to be same. That is what this property says. So let's see how to prove it. Now since A is a square matrix, for every square matrix adjoint always exists. See, I hope that you remember what the adjoint is. Adjoint is nothing but take the matrix and then replace every element by its cofactor and then take the transpose, that is the adjoint. Again, take the matrix and then replace every element by its cofactor and you have to take the transpose of it. Okay, so we are going to take 3 steps. How to find out the adjoint? First one is find the cofactors, okay, cofactors of each element and then take the transpose. Don't forget this step. Okay, this is important. So even after finding the cofactors, you are supposed to find out the transpose. For every square matrix, adjoint exists. So this step is like this. If A is a square matrix of order n, then both adjoint of A transpose, which means taking A transpose and then finding the adjoint, or finding the adjoint of A and then taking the transpose, whatever you do it, or square matrices of order n, which means the result is also square matrix, because we are taking a square matrix and then replacing every element by some other element which is called the cofactor, and so the resulting number of elements will be same, and again you are taking the transpose, so we get the same, right? Okay. Now the ijth element of adjoint A transpose equal to, so just follow these steps. I am talking about a particular element. So if you look at this adjoint A transpose matrix, then what do you think about the ijth element? Then ijth element will be jith element of adjoint A. How did you get this? This is some matrix which is transposed, isn't it? And now this is the transpose of this, right? Therefore, if there is an element ij, that element will be in the jith position in this, isn't it? See, if there is an element in the position of ij in a matrix A, then it will be in the position of ji in the matrix A transpose, isn't it? Therefore, if an element is in the position of ji in a matrix, then it will definitely be in the position of ij in the transpose of it. Therefore, these 2 steps should be clear. I think you understood these 2 steps, right? Let's go step by step. Now what did you understand? Ijth element of adjoint A transpose will be in the jth position of edge A. Got it? Okay. Now what do you think about jith element? How do you think we got this element from edge A? We would have taken A, right, and then we would have found out the cofactors and then we would have applied the transpose, isn't it? So adjoining operation is also involving transpose. How did we get adjoint A matrix? We would have taken the matrix A and then found out the cofactors and then found out the transpose of it. Therefore, how do you think we would have got this jith element? It is nothing but the cofactor of the ijth element. Think about it. It is not the cofactor of the jth element, it is the cofactor of the ijth element. The reason is, in order to find out the adjoint of A, we will first find out the cofactors and then we apply the transpose. Therefore, whatever element we got in jth position would have been the cofactor of ijth element of A, isn't it? Therefore, this element is equal to cofactor of ijth element of A. Got it? So this step is equal to this. So these steps should make sense to you now. So jth element of adjoint A is equal to cofactor of ijth element of the matrix A. Got it? Now what can you say about the cofactor of ijth element? Cofactor of ijth element is nothing but cofactor of jith element of A transpose. Are you getting this? Simple. I'm just taking the transpose. So whenever I take the transpose, ijth element will become jth element, right? Now what can you say? If cofactor of jith element of A transpose, if it is so and so, then we can write it like this. It is equal to ijth element of adjoint A transpose, which means we know this. If this is the matrix, and if we have to find out the adjoint of this matrix, what we do is we take the cofactors of this and then find out the transpose, right? Therefore, find out the cofactor of this. It is already cofactor is there, so ijth element of this one. Are you getting this? Let's go step by step here. See, these two steps you understood, these two steps you understood. Now let's see how do we get from this step here this one. There is a matrix called AT, right? Sorry, there is a matrix which is having cofactors, okay, of the matrix AT, this A transpose. Then how can we get the adjoint of this? We take the transpose of it, right? That is why I am getting the adjoint and then taking the transpose. Element is transposed. Got it? So what did we finally prove? That ijth element of adjoint of a whole transpose equal to ijth element of adjoint of A transpose. Therefore, these two matrices must be same. I'm not sure if you understood this or not. Anyway, if you didn't understand this entire proof, at least remember the result. Result is important. This one. Okay? Fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.